Hello. Okay. So now we change a scale. We go from bonds to atomic nuclei. Thank you for the introduction. I am Radovan Fiala, and I'm going to speak for facility of NMR spectroscopy that goes by the full name Joseph Dadok National NMR Center. So in my presentation, I will explain why the name is like it is, and I will mention what the NMR is good for, what you need to use our services. I will comment on equipment or the new, and how you can access our facility, how you can get financial support for your research. I mentioned people who you can meet in our facility, and I will illustrate the breadth of our work on a few selected publications. So our facility is named after Josef Dadok, who is a Czech engineer who started building NMR spectrometers for Academy of Science in the 1950s and 1960s, when this instrumentation was not easily available commercially. Since late 1960s, he worked and lived and worked in the United States, where he continued his research in the instrumentation and methods of NMR spectroscopy. He is still alive, and he is in contact with us, actively interested in what and how we are doing. Okay, so NMR spectroscopy is a spectroscopic method, but a little special compared to, let's say, UV or visible spectroscopy. The strength of the method is that it can provide detailed information, because we can get signals from individual atoms. We can work with both liquid and solid samples, and the measurement can do just brief or general information about whether the compound you have is what you expect, or it can be detailed that can study the structure, dynamics, and interactions of molecules, small and big. The advantage of the method is also it is very gentle to the sample. We do not break any bonds or anything, so it is essentially applicable even to living things. The downside of that is that the method is less sensitive than comparable modern analytical techniques. That means that you need a lot of samples. They should be stable, because the measurement can take time. And for the detailed studies, the data analysis can be quite laborious, and the equipment is very expensive. So what do you need if you want the service from us? You need, of course, a sample, and as I said, you need quite a lot of it. Generally milligram quantities. It has to be soluble for liquid samples in some common solvent. It has to be stable for the length of the measurement. The shortest measurement takes just a few seconds, but there is some preparation time, so you need something like 10 minutes stability. It is often the case, if you are not using NMR, that you come across an application that inspires you, that you say, okay, that would be nice if I can get the information on my sample. The best way is to send us the publication, and we can tell you, okay, we can do this or we cannot. The chances are that we can, because our equipment is quite extensive and quite flexible. So we can measure any common nuclei, any common type of spectra, and with some also special things, especially in the biomolecular field. So briefly about the equipment. So we have high-end NMR spectrometers, altogether 6 of them. with a magnetic field corresponding to the frequencies from 500 to 950 megahertz. All five of them are equipped with high sensitivity cryoprobes. And besides NMR, we also have a simple EPR spectrometer in our facility. We have nothing new this year, but the equipment was upgraded extensively in the years 2022. All spectrometers have completely new electronics, the latest generation from Bruker. We installed nitrogen liquefaction. Now we have a possibility to detect fluorine on all spectrometers because fluorine is becoming popular in biomolecular studies because there is no natural fluorine background. We can work with a wide range of temperatures. We also have a diffusion probe, which allows to measure the diffusion with reasonable accuracy for biomolecules, which can tell you about aggregation state of the molecules. Our future plans are extending in possibilities for the solid state spectroscopy, getting a probe from magic under spinning with fast rotation, which gives better resolution even for using proton. And also, what is in the making is combined EPR NMR system for hypolarized NMR. The equipment is being built by Peter Neugebauer's research group at the University of Technology, and it should be made running with our spectrometers here in our facility. So, who are our users? Our users are quite varied. The big part is FATEC research groups. It's essentially all about biomolecules, proteins, and nucleic acids. Then there are other users from Masaryk University, Faculty of Science, Medicine, Pharmacy. It is mainly organic chemistry or material science or prospective pharmaceuticals. And then there is a very varied range of users from academic users from outside the university, where the projects go from the basic methodological research up to fertilizers essentially. And then there are also industrial users. For them, we do mainly quality control, other the raw materials they use or products they make. So you can access our facility both in user mode or you can have the measurements done. So if you want to measure yourself, of course, you must know how to do it. If you do not, if you are not familiar with NMR, but you want to use it regularly, it is good idea to get trained. We have a training course, which is a normal course for students who get credits for that. But even if you are not a student or not even from Masaryk University, you are welcome to come and take part in that course. It is, let's say, the length is approximately like a driving school. We use the booking system that was already mentioned in the introductory talk. We also have our own monitoring system on which we can check each spectrometer, who is using, what experiment is running, and so on. And of course, it is available for the users as well. So you can distantly check even over the weekend also whether everything is running as you expect. If you measure yourself, we do not interfere with your data. We only do the backups. Of course, if we do the measurement, we will send you the data in a secure way. As I mentioned, NMR is quite expensive technique, so it would be prohibitive if you should pay the full cost of the measurement. Fortunately, there is financial support available, at least for academic users, and there are three biggest founding projects are listed here. The CISB is mainly for Czech users, but anyone in the world can apply. INEX Discovery is for transnational users from European Union. If you are interested, rather hurry because the project ends summer next year, and it is not clear how it will be with continuation. And there is also a European Instruct project, which is continuing. So the people you can meet in our lab, in red I highlighted topics for which you would interact with them, like Jaromír Toček responsible for the booking system, Petr Padeta creates accounts for new users. Otherwise, we have also the fields for which we do the measurements for outside users if they don't do it themselves. If you use these funding schemes, you get measurement for free or for a fraction of the cost. On the other hand, to make the system work, you are required to put acknowledgement in all the publications that use the data you obtain in the facility. For the users of Czech infrastructure for structural biology, note that there is a new project number for this year. If you use the old number, it's not the disaster. It's somehow followed for a couple of more years. But if you are writing a paper now, please use the new number. But there is a different acknowledgement required for the European project for the INEX Discovery, where we should state that the European Commission is not responsible for what you have measured. And even if you are not supported by anything, there is also a general acknowledgement text. It is important because based on that we are getting the funding. So if there are no acknowledgement, it could happen that there will be no more services. A few topics illustrated by the publication of the last year. There was very sophisticated method developments for solid state NMR done by Zdeněk Tošner from Charles University. The paper won Petr Sedmera Prize, which is awarded by the Czech Spectroscopic Society. Then there is a paper which falls into the material science. There is a paper about biochars, which is something that you can add to the soils to get better quality. And then, of course, our field is NMR of the biomolecules. So there are papers about proteins and nucleic acids. So with that, I thank you for your attention. The contact, the general contact with NMR, CETEC, MUNI, CZ, or by names of the facility members. The CETEC also provides access to social networks. So I'm an old dog, so I don't understand how anyone could look for serious information on social networks. But anyway, they are available both Facebook and platform X. I think it is called then now. And with that, and handprints of the use of our users on an old magnet, I thank you for your attention.
Perfect timing, Radovan. Thank you for that. We have still 5 minutes for your questions, maybe for one complicated question or two short questions, so don't hesitate to ask them.
Maybe what is the status of the project with Peternoike Power?
Last week we tested the probe, but not yet with the EPR, just for the NMR part. So they are working on that. They say the electronics is done. They are waiting for essentially only the cover, the box to put it in. Of course, they can test it electronically, but of course, whether it works in in connection with our NMR, it's going to be seen. But I must say that the probe was totally without the problems, because I was afraid, because they built something from the scratch, they brought it here, and I was afraid, okay, we put it in and there will be no response. That was not the case. We got immediately the signal. We were able to tune. We were able to shim. Though the line shape is not yet what we would like, but essentially it works. And so I hope that it will continue smoothly, because actually from 1 year from now, close to the next facility meeting, there should be an introduction of this system for EPR and NMR combination. So hopefully next year, if you come for the core facility day, a day after or the day before, you will have an opportunity to see this EPR and NMR technology in operation.
Okay, do we have? Could you please describe how the monitoring system works? You mentioned there's a monitoring system.
Right.
How it works, or?
Okay, so the spectrometer, when it's measuring it, writes on the disk files that carries the information about what experiment is being run, when it started, when it's going to be finished, and so on. And we have an online system that can read that information and can display. And we have also additional information for maintenance. For example, it checks how much helium, how much nitrogen is in the magnet, and based on the consumption in the past, it calculates the date when it should be refilled. So of course, this is not that much interesting for the users, only if there is this maintenance necessary. So the measurement has to be interrupted. So it may make sense for the user to look at it, but usually we put a reservation for the maintenance, and or if it happens that we have to jump into someone else measuring time, so we negotiate the time for the maintenance.
Okay.